Dot school presents adding and subtracting fractions. To add or subtract fractions, they need to be on the same denominators. For example, you could do 3 sevenths plus 2 sevenths is equal to 3 plus 2 all over 7, which is equal to 5 sevenths. But before you could do something like 3/4 minus 2/3, you need to find the least common multiple of the denominators 4 and 3, also called the LCM of the denominators, or the least common denominator LCD of the fractions 3/4 and 2/3. And in this case, that number happens to be 12 for 4 and 3. So you want to change both fractions to something over 12 so that you could go ahead and apply the rules for adding and subtracting fractions on the same denominator. The same rules apply when you add or subtract fractions in algebra. Therefore, a over d plus b over d minus c over d is going to be a plus b minus c all over d, because they are all on the same denominator d, provided of course the denominator is never equal to 0. If the denominator of a fraction is 0, it indicates division with 0, which is not allowed. But then to do something like a over xy plus b over yz minus c over xz, we need the LCM of these three quantities, or the LCD of these three fractions. LCM of xy, yz and xz is xyz, as all three of these can divide xyz. Now, you want to rewrite each one of those fractions as something over xyz. So to start with, a over xy is equal to something over xyz. If you look at this xy and this xyz, you'll probably realize that all we have done over here is multiplied xy with z. Therefore, to find an equivalent fraction, all you do is multiply the numerator and the denominator with z. Therefore, this is going to be nothing but az over xyz. Similarly, b over yz is going to be b times x over xyz. All we have done is multiplied the denominator over here with x, therefore multiply the numerator with x, which becomes bx. And in the same way, c over xz is equal to cy over xyz. Now we are going to replace each one of these fractions with their equivalent fractions with xyz on the denominator. The idea is to make them have the same denominator. So this is going to be az over xyz plus bx over xyz minus cy over xyz. All three of them are on the same denominator. Therefore, we can just add or subtract the numerators as we see the signs. az plus bx minus cy all over xyz. Let's do another example. 1 over p plus q minus q over p cubed plus q cubed. The idea is to factorize the denominators as much as you can in order to find their LCM. Now p plus q cannot be factorized, but we can of course factorize p cubed plus q cubed and rewrite that as p plus q times p square minus pq plus q square. That's exactly what we are going to do in the next step. Rewrite that as 1 over p plus q, there's no change over here, minus q over, replace the p cubed plus q cubed with the factored form, p plus q times p square minus pq plus q square. P plus q can divide p plus q times p square minus pq plus q square. Therefore, this is the least common multiple of the two denominators, or the LCD, least common denominator of the two fractions. So the idea is to rewrite both fractions on the same denominator. Well, there's no change in the second part. So this part remains as q over p plus q times p square minus pq plus q square. It's already on the LCM. The denominator is already the LCM of the two denominators. So we don't change this denominator. All we do is we want to rewrite the 1 over p plus q. We have a 1, we have a p plus q. But we need to write all of this over here so that they are on the same denominator. Therefore, that amounts to multiplying the numerator and the denominator with p square minus pq plus q square, so that the fraction doesn't change. It's still the same thing. And once you do that, you can simply combine the two, say that, okay, the common denominator is what we have, p plus q times p square minus pq plus q square, and then on the numerator we have a p square minus pq plus q square minus, it's this minus, q on the other one. Can this one be simplified? I don't think so. So that's how you add or subtract fractions in algebra.